Hi, second graders. Today we're going to be focused on day 8 in our math packet. I'm really excited to explore this with you. Let's take a look at our Unlock the Problem first. I'll read the problem. Jacob collected 70 baseball cards. He gave half of them to his brother Sammy. How many baseball cards does Jacob have left? What do we know? We know that Jacob has 70 baseball cards, but that he gave half of them away. Write that down in the first box. When you're done, come back. Let's take a look at the second box. What are we trying to find? We're trying to find how many baseball cards Jacob has left. The question is, after he gives half away, how many does he still have? Write it down right here. Press pause, and when you're done, come back. The next part of the question asks, what is the unit? What are we measuring or what are we counting? In this case, we are counting baseball cards. A little bit different today. Write down what the unit is right here. Press pause, and when you're ready, come back. All right. How will we use this information to solve the problem? This is a big problem because we need to find out what is half of 70. So we need to think about 70 as a whole. You can solve this a few ways. You could solve this on a number line. 70 would be at one end. 0 would be at the other end. And you would need to count all the way across. Ooh, that was a squiggly line. To find out what was in the middle. That's one way to do it. Another way to do it is you know that 70 is the whole. You are trying to find half of 70. You could skip count from either direction until you found the middle. For example, first I might add 5, and I would get to 5. If I take 5 away, I would get to 65. And I would keep skip counting backwards until I met at the middle. Whatever strategy you decide to use, write down your strategy here. Maybe it's skip counting, maybe it's on a number line. Decide what you are going to do. When you're done, come back. The last thing that you're going to do today on Unlock the Problem is solve it. Show your work for how you solve this because it's tricky. You are missing 2 parts. Maybe you'll solve it and make a number box like this, where 70 is the whole, and here's how many Jacob has, and here's how many his brother has. This is where you're going to write your answer. Write it down, and then come back. The last thing that we're going to do today is answer in a complete statement. So how many cards does Jacob have left? Your complete statement would be something like, Jacob has blank cards left. And write that down here. Parents, this is a tricky problem. It should require a lot of thinking on your child's part, and it should be more work than they've been used to. That's okay. If you have any questions, you can always check in with us. We are here to help. And parents, try and let them think through how to solve it. There's no wrong way to solve it. We're not even worried about efficiency here. We are worried about how well students are able to grasp this bigger problem. Let's move on to our work of the day. We're going to do some 3-digit addition to warm up our brains. Woo! Tricky. So we have 112 plus 159 and 471 plus 289. Now, second graders, I'm going to divide my paper here. Solving it this way is tricky. You might want to make a hundreds, tens, ones chart on your screen or on your paper so that you can solve it in there. You might want to model. Whatever you decide to do is fine with me. Take a minute, pause here, and do both of these problems, and then check back in with me and see if our answers match. Did you solve it? Let's take a look at what I did. On this first problem, I did a hundreds, tens, ones chart. I divided so that I was adding first my ones. 2 plus 9 is more than 10. So the ones go down here and the tens go up here. 2 plus 9 is 11. So 1 left and 1 10. Then I add my tens. Adding that 1 in, 1 plus 1 is 2, plus 5 is 7. And then I add my hundreds. 1 plus 1 is 2. So my answer is 271. Now, if you did it a different way, no big deal, as long as you got the same answer. Let's see what I did over here. I did a different model over here. On this way, I did model by using hundreds, tens, and ones. So first I did 471. 1, 2, 3, 4 hundreds. 1, 2, 3, 4, 5, 6, 7 tens. 1, 1. Then I did 289. 1, 2 hundreds. 1, 2, 3, 4, 5, 6, 7, 8 tens, and 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. I didn't count any of the blue because that's my addition. 9 ones plus 1 1 equals 110. So I circle my ones, draw an arrow, and move my 10 over here. I have 0 ones left. 7 tens plus 8 tens plus 1 10 is going to equal more than 10. So I know I'll need to make 100. Let's see. 7 plus 8 is 15, plus 1 is 16. So I have to circle 10 of them. Let's make sure that Miss White did it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I circled it and made it into 100 because 10 tens equals 100. Let's count how many tens I have left over. I have 1, 2, 3, 4, 5, 6 tens left over. There we go. And now I need to count my hundreds. 1, 2, 3, 4, 5, 6, and my new 100 makes 7. Remember, second graders, it is totally okay to add in the way that makes the most sense to you. Model if it helps. Let's switch our brains. Which of these circles shows a whole circle shaded? Take a look. If you answered that it's this one right here, you are correct. See how it's all colored in? This is one hole. It is a hole because it is all the way shaded in. There's nothing left out. This circle is not shaded in at all. So it's actually 0. There's nothing shaded in. How much is shaded in on this circle? Just half of it. Half of this circle is shaded in. So I'm making my fraction that says 1 over the number of halves there are. There are 2 halves. One of them is shaded in, so I will put 1/2. If that's true, then this fraction could be 1 over what is shaded in? 1. Or 2 halves over 2. Because it's all shaded in. If we shade in this whole thing, we are adding another half to it. Do you see? Good work. Take a look at these circles. Which of these shows 1/2 shaded? This circle shows 1/2 shaded. Here is the half that is shaded. Here is the half that is not. The half that is shaded, since it's divided into 2, I put 2 on the bottom and 1 at the top because 1/2 is shaded. What does this circle show? How many is it divided into? Let's count. 1, 2, 3. So what goes on the bottom? 3. And how many are shaded? Just the 1. So 1/3 is shaded in. This is also 1/3. And this is 1/3. So how many more thirds will we need to shade in to color it all the way in? We would need to shade in 2 more thirds. 1, 2. So that fraction would be 2/3. This is challenging stuff. What's important to point out is how many parts there are and how many parts are shaded. What is this missing part? This is divided into 2, so 2 would go on the bottom. And this part, there's only 1 of, so it would be 1/2. Good work, second graders. Let's look at some other shapes. A rectangle and a rhombus. Which of these shows 1/3 shaded? Well, we need to decide which one has 3 parts. So let's count. 1, 2, 3. Let's make sure this one doesn't. 1, 2, 3, 4. So on the bottom of this fraction, we would have 3. And this is shaded in just one of them, so it would be 1/3. What would happen if this was also shaded in? How many would that be? 1, 2. So it would be 2/3. Tricky. Let's take a look at the rhombus. How many are shaded in the rhombus? 1. How many parts are there altogether? 1, 2, 3, 4. So this fraction would be 1/4. How much is shaded on this square? We wouldn't just say 1 is shaded, because if the whole thing was shaded, then it would be 1. But there are some parts that aren't shaded, and then we need to represent those parts. So how many parts is this square? Let's count. 1, 2, 3, 4. 4 parts. And out of those 4 parts, 1 is shaded, so that 1 goes up on top. Let's take a look at some of the work that you'll be doing today. When we take a look at this work, it might look or feel a little different than these colorful shapes. But guess what? You just did a bunch of hard work and hard thinking. So let's take a look at the next problem set. This is asking 2 different questions. First, it's asking how much is shaded. Let's focus on that how much is shaded first. Remember, we need to identify how many parts are shaded. First, we need to think about how many parts there are. So in A, there are 3 parts. That goes on the bottom. How many parts are shaded? 1. 1/3 is shaded. Let's try B. First, how many parts are there? 1, 2. There are 2 parts. How many parts are shaded? 1. What is this fraction? 1/2. 1/3, 1/2. Here's where it starts to get a little bit trickier. Let's look at C. How many parts are there? Let's count. 1, 2, 3, 4. So 4 goes on the bottom. And how many parts are shaded? This is tricky. 1, 2. So 2 goes on the top. 2/4. What about for D? Count how many parts. 1, 2, 3. 3 parts. And how many are shaded? 1, 2. 2 parts are shaded, so that goes on top. This is a new word. This word is 2/3. What about E? What is E divided into? Is it divided into fourths? No. Is it divided into thirds? No. It's divided into halves. Because it's divided into halves, 2 goes on the bottom. And what part is shaded? One part. Let's look at F. How many parts are there? There are 4 parts. So it's divided into fourths. How many parts are shaded? 1, 2, 3 fourths. So we did step 1 of this problem. Now it's asking a different question. It's asking, how much more do we need to shade to make one whole? Remember, a whole is when it's all shaded. How many more parts would we need to shade this? A. Here's another third. Here's another. How many did I shade in? I shaded in 2, but it's still divided into 3 parts. So it would be 2/3. 1/3 plus 2/3 equals 1 whole. What about for B? Let me color it in. Oh, I only needed to color in 1 part. So 1 would go on top, but it's still divided into 2, so 2 goes on the bottom. 1/2 plus 1/2 equals 1 whole. Let's look at C. 1, 2, 2, and it's still divided into 4 fourths. 2 fourths plus 2 fourths equals 1 whole. Two-thirds have been shaded in here. I want to shade in the whole thing, so I have to shade in, just 1 more part. There are still 3 parts, but only 1 needs to be shaded. Second graders, look at this one. This circle is just the same as this square because it's 1/2. What else would equal, what plus this 1/2 would equal 1 whole? 1/2. Now, if you still aren't sure, you can always shade it in. How many parts did you shade in? You shaded in 1. How many parts is it divided into? It's divided into 2. Last one. I need to shade in, just 1 more part. How many parts are there altogether? 1, 2, 3, 4. One fourth plus 3 fourths equals 4 fourths. Good work, second graders. Let's take a look at today's work. For parts A, C, and E, you need to identify the shaded area. So how many halves? 1/2. How many halves? 2 halves. So you'll do that for A, C, and E. B asks a different question. It says, circle the shape above, so for part A, that has a shaded area that shows 1 whole. D says, circle the shape above that has a shaded area that shows 1 whole. And F says, circle the shape above that has a shaded area that shows 1 whole. All of this is practicing for those fractions that we've been talking about. You guys did an awesome job today. Send us a picture of this finished work. If you have any questions, please reach out to your teachers. We are happy to help. Have a great Wednesday.